My name is Marco Capoferri. I'm the sales manager for the SEI Laser, taking care about the corrugated application. We are exhibiting here in Print4All with some machinery for labeling, for converting area, generally speaking, including the corrugated. Of course, the solution that we propose for the corrugated as a finishing line, complete finishing line, cutting, creasing, pallet to pallet is named X-Wave converting, and unfortunately too big to be shown in the show. Is nearby 17 meters length line, and but we are showing some samples that we have done with this machine. The concept of the machine is end-to-end, so pallet to pallet, complete finishing line for corrugated sheets. The working area, the size, maximum size for the sheets is going to be 1600 by 2400. The main characteristic of the line is the cutting station is based on the laser technology, and this is something that is completely new in this market. As a flatbed solution with the laser technology, we already know solution based on cutter, on routers, and VCut and so on, mechanical, let's say, approach. In our case, the cutting is made by laser. The creasing station is a traditional creasing tool, rounded, so for the physical creasing. Then we have the feeder and the sticker station, and the alignment table, the reference table for the alignment of the process with the real position of the sheet. What is the main advantage of the machine? The main advantage is basically the productivity, because compared to the traditional knife flatbed plotters, we are going to have from in the worst case 3-4 times, in the good case up to 7-8 times more productivity, more output from the machine. I can show you later on a video regarding showing the machine in the process. In this moment, I can show you a couple of samples that we have done with machine. So this is a display, very basic display. My customer is naming the display New Yorker. It's a real display you can purchase. It's available online. And there is a kind of customized box, because the two main application for this machine is the packaging, custom packaging, and the custom display. The target of the machine is to optimize the finishing process for the, let's say, corrugated, printed or not printed, whatever, corrugated sheets from 1 millimeter single wave, also cardboard in case, up to 7-8 millimeter double wave or triple wave, whatever. So we don't go over this size because the creasing station is with some limitation, and we think that this limitation is going to be not a problem in the real production, because the main application for this market we are focusing is working with 3.5, 3, 4, 5 millimeter maximum. For example, this kind of display that is developed on the 2 meter square corrugated sheet is a double wave EE 3.2 millimeters thickness. Is processed with a productivity of output of 120, more or less, displays hour. So 120 displays hours means more or less 240, 250 square meters hour capability. That is exactly the productivity, the output you're gonna have from the latest, the most advanced flatbed multipass printers, like I don't know, Dust, for instance, the water-based ink from Dust, inkjet printer from Dust, for instance, is declaring up to 250, 300 square meter hour water-based ink. And so another advantage for the laser process coming from the laser process is the possibility for the laser to do any kind of shape that without any limitation. That is something that with the traditional cutter you have. The other advantage of our machine is pallet to pallet continuous workflow. So the sheet is never stopping, and this is minimizing the waste of time in the pallet to pallet.
Carlo, can you show your?
Yes.
Okay.
So the machine is the line is a line, complete production line, finishing line. Is composed by 5 stations. The first station is the feeder on the right, automatic feeder that is positioning the sheets on the reference table with the scanner camera, provider scanner camera, that is recognizing the orientation of the sheet. Then the sheet is going inside the creasing station, mechanical creasing station with a specific conveyor developed for the creasing. So we have the feeder, the reference with the laser, the scanner camera that is recognizing the dots and the position of the real orientation of the sheet. And then the creasing tool is starting the job. The interesting point is that the creasing station is working without stop the material. So the material is traveling inside the machine. The speed of the material, the speed of the conveyor is automatically adjusted by the software.
Interesting.
So we don't have a stop and go that is a losing of time.
Yeah. Oh.
Then after the creasing station, we are changing the conveyor. We go on a different, the second module that is exactly the same technology, same motion control as the first module, the creasing module, but based on laser technology. Of course, we are going to cut, perforate, micro-perforate the material, all the process related to the complete cutting, complete perforation. And we do this process thanks to a specific patented conveyor that is allowing the laser process to make the job without damage the bottom of the material that is printed, actually, because the printed side is in the bottom. At the end of the cutting station, there is the stacker, and the stacker is working exactly as the feeder station with the vacuum system, provider of conveyor, and releasing each panel, each sheet on the fly without stop the process. So the speed of the process is of course, as for every digital finishing process, is depending from the say the layout, the cutting and the creasing layout. Usually, 99% of times, the bottleneck of the process is the cutting, is not the creasing, is not the printing, because the printing is going, as we told before, the digital printer our output can be easily 200, 300 square meter hour. In the case of the finishing, the output is depending from the layout of the cutting layout. So the display we showed to you before is taking 25 seconds, more or less, process time in the cutting station. But the creasing process, as the loading and loading and everything, is made in hidden time. So the speed of the line is depending from the cutting station. And because in the laser process, the cutting is very fast, we are able to reduce this process, the cutting process time, a few times compared to the traditional mechanical cutting stations. This is, let's say, the latest and the most advanced technology you can see in this show, but maybe worldwide, for the finishing of corrugated, digital finishing of corrugated process.
Thank you, Carlo. Very interesting. Thank you so much.